Okay, sweet. Okay, so we are in a new chapter. We are still, I mean, essentially we're still talking about atoms and the structure of an atom. We've talked a lot about the nucleus and kind of the overarching stuff of there's protons, there's neutrons, how do you calculate the mass or the charge of an atom. This entire chapter that we're about to get into is basically just the electron cloud. There is a lot more detail to the electron cloud. Sorry, is this distracting? Is it okay? Okay, it's nice. Background noise. There's a lot more detail to the electron cloud than we've discussed so far, and there's a lot more detail to how electrons are arranged within the electron cloud. Okay, so I said before that we don't know exactly how the electrons move. They kind of move in unpredictable paths, and you can't really know, but we do know a lot about their energy, and parts of the cloud that they spend their time in. Even if we can't track them specifically, there's a lot of information we do know about electrons, and it's important for how atoms behave, and it'll play into what we talk about later. So that's what this chapter is about. So we're just going to start real simple. We're going to talk about the electron cloud and then break it down into its subcomponents. So energy levels, sub-energy levels, and orbitals. So the subcomponents of the cloud. Okay, so just as a quick reminder, we know that atoms have electrons. Okay, we know that those electrons are in the cloud. Okay, and we know the electrons move in unpredictable paths. Okay, so a good model of our atom is something like this. The nucleus is really, really tiny, okay, on the femtometer scale, but then we've got this giant electron cloud where the electrons spend most of their time, okay? But there's a lot more detail to this that we need to unpack, okay? So, first thing we need to talk about are energy levels. I've kind of mentioned already that the cloud has energy levels. More specifically, okay, there are 7 of them. Okay, electrons can occupy different energy levels of the atom. Okay, and these are known as principal energy levels. Okay, so the main energy levels, they're also commonly called shells. So electron shells. The periodic table actually tells us how many shells there are. The number of shells for a low energy atom can go up to the number of rows on the periodic table. How many rows are on the periodic table? 7. That was on the test, right? Okay, so they can be labeled 1, 2, 3, 4, 5, 6, 7. Okay, so you can kind of see over here, this is kind of a diagram showing how the energies are separated. So energy level 1 would be low energy, right? Energy level 2 has more energy, and then 3, and then 4. You'll notice that they get closer together as you go up. If I were to go to 5, 6, 7, they get all really close together. Anyone here in calculus? Anyone here in calculus? Okay, never mind. I won't make a calculus reference. There are technically an infinite number of energy levels, and they get closer and closer and closer. But for energy levels on the periodic table, we go to 7. Okay, it is possible for electrons to jump to higher energy levels, but when they're in their low energy resting state, they're going to be either 1 through 7. Okay, so there's 7 of the low energy levels where the electrons can rest. Okay, but they technically can jump up to higher energy levels. Okay, so we've got 7 principal energy levels. Okay, and we just label those like that, okay? And like I said before, it corresponds to the periodic table. There are 7 rows in the periodic table, and so the idea is that when I go to a new row of the periodic table, I am adding an energy level to those atoms. So when I go from neon in row 2 to sodium, one reason that sodium is on the next row is because it now has a 3rd energy level available for the electrons. Okay, and then I go to the next row. Now there's 4 energy levels on those elements. Okay, so that's why there's 7. I think this is getting louder. I'm gonna turn that off. Okay, you may have been told in physical science that each row represents an energy level. That's not entirely true. So if that's in your brain, that's like only half true. Okay, we are adding a new energy level when we go to a new row, but the whole row isn't just representing one energy level, okay? And we'll get into more detail with that later, okay? But I don't want to tell you wrong up front. Okay, but it does correspond to the periodic table. 7 rows, 7 energy levels, okay? So we've got that. Then the energy levels break into sub-levels, okay? Sub-energy levels. Okay, these are also referred to as subshells. Okay, you have shells and subshells. Okay, so what we're doing here is we're talking about how we can organize the electrons based on their energy. Okay, this electron has this energy, this electron has this energy, and we can organize them based on that energy. Okay, so the main category is the energy levels, and then there's subcategories of the subshells or the sublevels. Okay. So here's the interesting thing. You have a different number of sublevels depending on which energy level you're on. So the way I kind of think about this is you can think of like the electron cloud as a hotel. Okay, we know that hotels have different floors, first floor, second floor. So say this hotel has 7 floors. You could think of the sub-levels as hallways. Okay, I have this hallway with rooms in it, and then maybe on this floor I have these other hallways where I can go to these different hotel rooms. You have different number of sub-levels depending on which energy level you're on. So in the hotel analogy, you have a different number of hallways on each floor of the hotel. Okay, so there's a pattern that we're going to have to learn. This pattern's pretty easy. Okay, on the first energy level, first principal energy level, I only have one sublevel. So on the first floor of my electron hotel, where the electrons are going to live, there's only one hallway. On the second energy level, there's 2 sublevels. How many sublevels do you think are in the third shell? Great guess. It is correct. Okay, and the pattern's going to go from there. Okay, I'm not going to go all the way up to level 7, okay, but the pattern follows. Okay, I'm going to stop at the 4th energy level. On the 4th energy level, there are 4 sublevels. Okay, so on the 4th floor of my hotel, I have 4 different hallways that the electrons can spend their time in, so to speak. Wow. So much noise happening. Okay, we're cool with this so far? We have energy levels, and then within those energy levels, there's sub-levels, okay? Now, the sub-levels are labeled with letters. Okay, and so we're going to have to learn the letters that are used to label these sub-levels, okay? It's kind of a weird system. I can look up why it's these letters and not just like A, B, C, D, but it's not just A, B, C, D. It's different, okay? The first sub-level is called S. Okay, and if it's on the first energy level, we call it 1s. Okay, so it's the S subshell on the first energy level, so we call it 1s. Okay, so that's the name of that sublevel. On the second energy level, there's an S subshell, but we would call it 2s, right? But then we have another one called P. So on the second energy level, we have 2s and 2p. Not sure why we're choosing these random letters. There might be a reason, but I don't remember it off the top of my head. Okay, on the third energy level, we have an S, we have a P, but then there's a third one. You want to guess what letter that one is? Good guess, it's D. 3s, 3p, and 3d. So these are my 3 sublevels that the electrons can occupy if they're on the 3rd energy level. Okay, if I'm on the 4th energy level, I have a 4s, a 4p, and a 4d, but then there's a 4th one I get now. You say A? Oh, in? No, it's not in. It is F. It's not Q, sorry, no Q. We have 4S, 4P, 4D, and 4F. These are all the sub-levels on each energy level. You have different energy levels, or sub-levels, depending on the energy level you're on. Okay, these are where the electrons are going to spend their time.
So we don't know what those letters mean?
I don't know what they stand for, and I don't know if they stand for anything. It's just like a label. Okay.
I didn't know if they meant like I figured the S was sub-level, so I didn't know if that could be, I didn't know if they had a specific.
I don't know. I don't think it's short for anything. There's going to be pictures for these of like, here's like a chunk of the cloud where this electron spends its time, and it's just labeled, this is S, this little blob where the electron lives. But yeah, I don't know if it stands for anything. Okay. Good? Can I keep going? Okay. So, oops. Ta-da. Okay, I already said that. So this is just a little graph just to kind of show this in a more visual way. Okay, so I've got my 4 energy levels, 1, 2, 3, 4. Okay, on the first energy level I have 1s. Okay, 1p, 1d, 1f is not a thing. Those do not exist. There's no such thing as that. Okay, on the second energy level, 2s and 2p. 2d, 2f is not a thing. Okay, third energy level I have those 3. And then over here I have those 4 sublevels. Okay, so same thing I just showed you, just, I don't know, in a table form. Okay, so we've got that. So we've got our sublevels. Okay, now here's the last subdivision below that is my sublevels, or my subshells, can then be broken down into more specific energies called orbitals. Okay, and the orbitals are like the rooms in the hotel. So it's like I've got floors of my hotel, then there's different hallways depending on what floor I'm in, and then there's rooms that the electrons can go in those hallways. Okay, and those are like the orbitals. Okay, these are little pockets of the cloud where the electrons can spend their time. Okay, and I'm going to show you pictures of these here in a minute. Okay, so the sublevels contain different numbers of orbitals, and there's a pattern for how that works. Okay, if I have an S sublevel, so whether it's 1s, 2s, 3s, 4s, it doesn't matter which one. If there's an S subshell, it contains one orbital. Okay, one pocket, so to speak, where electrons can spend their time. Okay, and this is true on all the energy levels. If there's an S subshell, you get one orbital in that subshell. If I have a P subshell, I get 3 orbitals. So 3 metaphorical hotel rooms where electrons can spend their time. Can you see the pattern? If I have a D subshell, how many orbitals do you think I get? I get 5, yeah. 5 metaphorical hotel rooms. That was hard to say. And then if I have an F subshell, I get 7 orbitals. Okay, do I have the... Okay, and the orbitals are just named based on what subshell they're in. Okay, so I have an S sublevel on the first energy level, the second, the third, and the fourth, right? We have 1s, 2s, 3s, 4s. Those orbitals are just labeled the same way. Okay, so you would have S orbitals on whatever energy level you're on. if I have a p subshell, those orbitals are just called, they're just labeled the same way, 2p, 3p, 4p, wherever, whatever energy level you're on. Notice there's no 1p, right? 1p was not a thing. Okay, and same idea for the other ones. Okay, you name the orbitals based on what subshell they're in. Okay, same naming system. Okay, these are the little pockets where the electrons are going to live within the cloud, the overall cloud. Okay, do I have the 2 electron thing on here? Okay, I basically just said that. Okay, they're labeled based on the energy level and the subshell that they're in. Energy level, subshell. Energy level, subshell. Okay. So, scary diagram. These are what all of the orbitals in an atom can look like. So notice what's happening here. We've got our energy levels, 1, 2, 3, 4, 5, 6, 7. S, how many p orbitals were there in a subshell? P, what is 3, right? P, right? 5d subshells, and then 7 of the F's. Okay, and look, they have all these weird, freaky, different shapes. Okay? And so what these are is these are little pockets where the electrons can move around inside of those orbitals. Okay, that's, again, assuming an electron is a particle. We kind of discussed earlier that it could also be a wave. So maybe it's just a wave that vibrates in this shape. Okay, so electrons are kind of weird. But the point is, these are like, if I took my whole cloud, which is a blob, and broke it into the subcompartments and spread them out, this is what they would look like. Okay, so let's look through this one piece at a time. Okay, because that's a lot to take in all at once. Okay, let's get into this. Okay, so reminder: an orbital is a subcomponent of the cloud. It represents a statistical number, where within this pocket, the electron will spend 90% of its time. The other 10%, it could be anywhere else, we don't really know, but 90% of the time it's in this pocket. Okay, whichever pocket you're talking about from this chart, okay, it's going to spend 90% of its time there. Okay, orbitals are the smallest subdivision, okay, so there's nothing smaller than orbitals that we're going to talk about. Here's the other thing that I want to say. Each orbital, regardless of where it is or what type it is, can hold up to 2 electrons. Okay. Electrons like to follow a buddy system. If they can, they will pair up. Okay. Obviously, if you have an odd number of electrons, then one of them is going to be on its own, in its own orbital. But for the most part, they will try to pair up if they can. Okay, and once an orbital is full with 2 electrons, all the other electrons have to go into some other orbital. You cannot fit more than 2 electrons in one orbital. Okay, so this is the pattern that we are going to start to investigate here. Okay, and so the orbitals each have a unique shape, and I'm going to go through and show you those shapes. Once you finish this slide, this is a good breaking point for softball to head out. Cool. Fair enough. Good luck. I hope you win all your games. All right, for the rest of us, let's talk about these orbitals. So what I want to do is I want to go through each type of orbital, S, P, D, and F. Can't hold 4 in the pen at the same time. S, P, D, and F, and look at what they physically look like. What do their shapes look like? Okay, so we'll start with S. Okay, S orbitals are spherical. Okay, maybe S stands for sphere, but that pattern's going to fall apart with the other letters. So maybe it's just a coincidence that S and sphere start with the same letter. Okay, so we know that S subshell has one orbital. Okay, the S orbital. They are spherical. They look like this. A little ball. Okay, where two electrons can move around or vibrate if it's a wave. Okay, we don't know which one it is really, or maybe it's both. Okay, so that is an image of what an S orbital looked like, and notice how it's labeled 1s. So that means this orbital is on the first energy level, and it's in an S subshell, so we call it 1s. That's a 1s. Okay, and you can tell that it's an S orbital just by looking at it. If it's a sphere, it's an S. Okay. Now, an interesting thing about these is we did talk about how, yes, there's a 1s, but there's also an S orbital on the second energy level, right? There's a 2s, then there's a 3s and a 4s. Those orbitals are the same shape, but because they're higher in energy, they're larger. So let me show you that, okay? They're labeled according to the principal energy level, the subshell that they're a part of, okay? So that's S. On the first energy level, I have that, okay? But if I go to a higher energy level, they'll have the same shape, but they increase in size. So if I were to go to the second energy level and look at the 2s orbital, it is a sphere, but it's larger. That's what the 2s orbital looks like. Even though it's bigger, it only holds 2 electrons. Okay, those electrons just have more energy, so maybe that's why there's more space for them. I don't know. Same shape, just larger. If I go to the third energy level, there's another s orbital up there too. It's just larger, but the same shape. And then so on, 4s, 5s, they get bigger and bigger and bigger as you go up. You don't have to worry about the axes, like you don't need a like X, Y, Z axis. I just want us to know the shapes. Okay, we are going to need to know what the shapes look like. Okay, so these are what S orbitals look like. They are a sphere, and they are larger or smaller depending on which energy level they're on. Cool? We okay with this? Okay. Let's talk about p orbitals now. Okay, p orbitals, okay, are on p subshells, and they come in groups of 3. If I'm on a p subshell, there are 3 p orbitals that are on that subshell, okay, and they are dumbbell shaped. That's the best way I can describe it. Okay, they look like this. Okay, technically you can further label them as to like how they're oriented. You don't need to worry about that. P, Z, just call them P, okay, and just know that there's 3 of them. And they are all perpendicular to each other, okay? So this whole thing represents a P subshell, and then within that subshell I have 3 P orbitals where electrons can be. And these are kind of separated from each other. If I put them all together on one atom, it would look like that. Right, so those are different colors, so you can see which one is which, and they're all perpendicular to each other. So how many electrons could I fit in total in these orbitals? 2 times 3? 6, right? 2 for each orbital, and I have 3 orbitals, so that I can fit 6 electrons in a p subshell. Okay, and so they have this kind of dumbbell shape. Okay, so what I'm going to do is I'm going to start building up a diagram. If you want to make this off to the side or on a separate paper, I'm going to come back to this as we go through the slides, just as kind of like a review of what we've talked about. Okay, so on the first energy level, I have an s orbital only, right? There's no 1p, there's no 1d or f. I just have 1s, so I just have that orbital on my first energy level. Okay, this is like the first floor at my hotel where the electrons can live. If I go to the second energy level, I have an s subshell with 1 orbital, but I also have a p subshell with 3 orbitals. Okay, same shape but larger, but then I also have my p subshell. Okay, so these are all the orbitals that I can have on my second energy level. Okay, on my third energy level, I have a 3s and 3p, so notice, larger, same shape. Okay, and then here in a minute, I'm going to show you the other orbitals that are also on the third energy level, but I'm kind of giving us a visual representation of how the electron cloud can kind of be broken down. Okay, leave yourself room. I'm going to go up to 4 energy levels, and then we need to go all the way to like 4f. Okay, so however, if you want to make this diagram, leave yourself some space. We'll come back to it. Can we do d orbitals now? Okay. D orbitals only show up once you get to the third energy level, right? So we start with 3d. Okay, and on a d subshell, you get 5 orbitals, like we said a minute ago. They are kind of dumbbell shaped, but there's multiple dumbbells in one orbital, and then one of them has a donut. Okay, the fancy math term for donut is torus. Okay, but it's a donut. These are what d orbitals look like. Kind of weird. This is one orbital, this is an orbital, that's an orbital, that's an orbital, that's an orbital. Okay? How many electrons can go in each one of these? 2. I can put 2 in here, put 2 in here, 2 in here, 2 in here, 2 in here. Notice how 4 of them are the same shape. This, and this are all the same shape, they're just oriented differently. And then we have this oddball with 2 lobes and a torus around the middle. Okay, and yes, there are more specific labels for which one is oriented which way on the, on the graph. You don't need to worry about that. Just know how to recognize them. If it's a cross or has one donut, it's one of the d orbitals. Okay, I don't care about us knowing which is which. That's what college students care about in chemistry. Cool. We've got these. We're going to need to learn how to recognize these, but we'll come back to this a bunch. Okay, so if we go back to our diagram, first energy level, I have 1s, 1s. On my second energy level, I have 2s and 2p. Grand total of 4 orbitals, right? On my third energy level, I have 3s and 3p, but then this is also where I have 3d. So I have to add all of those orbitals on the third energy level as well. Okay, so we're filling out our little electron hotel, so to speak. So I can put 2 electrons here, 2 can go here, 2, 2, 2, 2, 2, 2, and 2. Okay, so you can fit a lot of electrons on the third energy level. 18 specifically, if you fill it up. Ready to talk about the f orbitals now? Can I move on? Okay. We're winding down here. Okay, f orbitals don't show up until the 4th energy level. Okay, and when I get to an f subshell, I have 7 orbitals in that subshell. And they are very complexly shaped. Okay, this is just me describing it. You don't have to write this down. Okay. They look like this. Lots of different shapes. even though they look super complex, you can only fit 2 electrons in each one. Okay? So notice how these 4 look the same. Right? You kind of have 6 lobes, but each of these orbitals is just oriented differently on the axis. So they are different. Okay, 6 lobes. These 2 look the same. There's 8 lobes in kind of a cube shape. Again, they're just oriented differently. And then, kind of like in the D subshell, you have this oddball where I have 2 lobes, but then 2 tori, donuts. Okay, so they're shaped kind of weird. Okay, but you can only fit 2 electrons in each one, just like before. I might have you draw these like a couple times in this chapter. What I want you to be able to do is recognize it. If I show you a picture of an orbital, you need to be able to tell me what type it is. Is that an S? Is that a P, a D, an F? So that's the main thing. So maybe it's worth writing down in your notes right now, but don't freak out that I'm going to have you like draw these and then like take away artistry points or something like that. I just want you to know what they look like. Okay, so recognition is really all I'm going for these. So in an F subshell, this entire subshell, I can fit 14 electrons, right? These are like little hotel rooms. I can fit 2 in each room. So potentially I could go all the way to 14, assuming I have that many electrons to put in the atom. Okay, so now I'm going to add these back to our little chart here. Okay, so my first 4 energy levels. On the first energy level, I have 1s. Next energy level, I have 2s and 2p. Next energy level, I have 3s, 3p, and 3d. On the 4th energy level, I have 4s. Notice how continuing to get larger. I have 4p. Okay, I'm just trying to, I like zoomed in the picture just to make it look bigger, right? I have 4d, and I have 4f. So I have all of these orbitals available for electrons to occupy on the 4th energy level. It's kind of a weird hotel. It like gets bigger as you go up. Okay, but maybe that's where the analogy breaks down. Quick math. How many electrons can I hold total on this energy level? If I filled everything up, how many electrons could I fit up here? 22?
I know.
I think it's more than that. Yeah, it's 32. You can fit up to 32 electrons just on this energy level, potentially. Okay, I could keep going, but I think we get the pattern of, on the 5th energy level, I would have 4s, 4p, 4d, or I'm sorry, 5s, 5p, 5d, and 5f. Technically, there's like g orbitals, but those don't show up on the periodic table. You have to go off the periodic table to get to those, so we're not going to worry about it. Okay, but we need to know what S, P, D, and F orbitals look like. Cool? Okay. So I think we're going to summarize here. Oh, another picture just kind of showing the shapes. Okay. So we'll just add, so this is a chart just to add up how many electrons we're dealing with on each energy level. Okay, so here's my energy levels, or the first four. Okay, I have S, P, D, and F. S subshell has 1 orbital, 3 orbitals in a P, 5, 7. On the first energy level, I have 1 S only, which is 2 electrons, right? 2 electrons times 1 orbital, 2 electrons. Okay, I don't have 1 P, D, or F, so on the first energy level, I can hold up to 2 electrons. Okay, on the second energy level, I have a 2s, which can hold 2 electrons. I have a 2p subshell, 3 orbitals times 2 electrons each is 6 electrons in the p subshell, yeah? There's no such thing as 2d or 2f. So in total, on the second energy level, I could have 8 electrons. How many electrons can I put on the third energy level? 18. Sounds right to me. I have 2 electrons in my S subshell, 6 in the P, 10 in the D subshell. There's no such thing as a 3F, so that's 18. And then we already discussed you can have up to 32 electrons on the fourth energy level. And then, you know, it goes on from there. So this is our introduction to the electron cloud. Last chapter I said, it's a cloud, there's electrons. Okay, there's actually way more complexity to how the electrons are arranged within the cloud. This acts as our introduction of what the different parts are. Then we're going to spend basically the next week and a half just talking about how you fill up. As you add electrons, they go into certain parts of the cloud in a certain order. So the way you fill up the orbitals with electrons matters. So we're going to talk about that as we go forward. Perfect timing. Okay. No work today. We'll work on stuff tomorrow. We'll see you guys later.